Progressive JSON. I wrote this post yesterday. This is a post about the data format that is being used internally by React Server components. I did not expect it to pick up so much traction, but it got on the first page of Hacker News, and there was quite a bit of discussion, and so I thought I would also make a video form of this post. I'd like to start off this post with an analogy, and the analogy I'm using is progressive JPEGs. If you started using the internet around the same time as I started using it, which was about 20 years ago, maybe a bit more, you must remember that images were loading pretty slowly at the time. And so there are different ways for a browser to load the image, and it depends on the image format. One interesting thing about the JPEG format is that it supports two different modes of loading. The default mode is top to bottom, so at first you see the top of the image, and then more of it loads, and then eventually you see the whole image. And again, if you've been using internet for a while, you must remember what it feels like to wait for the entire image to load. That used to be quite slow. But JPEG also supports there's a different version of the JPEG format, or like a different, like when you save a JPEG file, you can choose a format called progressive JPEG. And in this case, the information is structured a little bit differently. So the browser can actually show kind of a low resolution version of the image first. And then as more data streams in, it's able to kind of gradually refine it until the picture gets crispier and crispier, and then you see the whole picture as the final stage. So in my post, I'd like to take this analogy and apply it to JSON. Can we stream JSON progressively? And what would it actually mean? Let's start with a small concrete example. Here is a JSON tree with some data. It's got a header, a footer, some contents for the post, and some comments on that post. And so suppose you want to transfer it over the wire. So you want to transfer it from the server to the client. But because the format is JSON, we can't actually do anything useful with it until the very last byte arrives, right? Because when you want to use JSON from the server, do something with it, the first thing you need to do is to parse it, to call JSON.parse. And JSON.parse only accepts the full JSON object. You can't give it a part of the object. So this means that if for some reason producing that JSON is slow on the server, so maybe producing these comments take a database call, and so the server is kind of stalling and waiting on that call, then the client can't even start doing anything useful with this JSON. The client can start any work until the server finishes all the work. And of course, that's how we've been doing things all this time, but it doesn't hurt to ask, can we improve on this? Can we do anything better? Let's first talk about streaming. So the first idea we could have is to, because the server sends the JSON byte by byte, we might think, well, what if we read it byte by byte and actually construct the object tree as the response is arriving? And so this object tree would have some holes, right? So if we got only partial content down to the second comment, the third comment will be missing, the footer will be missing, but at least we'll have like a partial tree received from the server just as the JSON is streaming in. So if you actually try to implement this approach for a kind of traditional UI application that wants to show this data, you'll find out why it sucks. And the reason it sucks, there's multiple reasons. One is that the objects are kind of malformed. So the types don't match. So for example, this root object, it was supposed to have the footer property, but the footer property is missing. So any code that tries to read it would crash. We don't know that it's missing. There's no indication of which properties are coming later. Also, for example, here we only know that there are two comments, but we don't know if any more comments are coming. So in practical, even if we stream JSON, we can't really take advantage of it on the client. So we don't know what's complete and what's not, and that's why streaming JSON isn't popular, aside from some niche use cases where you actually have, like let's say maybe you're streaming in megabytes of data, and then you have some custom logic that can handle incomplete JSON and do something useful with it. But this logic would have to be written for a very specific use case, so it's not very general. Anyway, this is the same approach as we see with normal JPEG, not progressive JPEG. So it kind of loads top to bottom. And it's also the same approach that HTML itself uses when streaming, right? If you've been on a slow connection, you might have sometimes had this happen when a page has streamed in partially, and so maybe you see the header and the sidebar, but the content hasn't loaded yet, or maybe you see the article, but like half the comments have loaded. And in some ways, this is helpful. Like the user can see the contents of the page a bit earlier, but sometimes this also messes things up, right? Like you've probably had cases where the sidebar takes the whole screen because the layout hasn't fully loaded yet, or it's just unclear if more content is coming or if it's become cut off. So it's also not perfect. It has its downsides with HTML as well. One of the most notable flaws of the HTML approach to streaming, which is just top-down streaming, is that if something in the middle is blocked or slow, like let's say the server is blocked on actually fetching the comments from the database, then everything below it kind of stalls, right? Because the server can't emit HTML that should come after, like the footer, even if in theory sending the footer would be easy and we could have the whole page's layout arrive sooner. But because something along the way is stuck, everything below it is also stuck. And so this is kind of a flaw of top-down streaming. One slow thing delays everything below it. There's actually another way to do streaming. The approach we've taken to streaming so far is that we stream depth first, which means that when the top level object has a property called post, we go into that property, and then if it has the comments property, we go into that property, and so we kind of send things as we traverse deeper into the hierarchy, and we send things off, and then if something is stuck, then the rest can't continue. But we could actually send the same information in a different way, in breadth first way. So what I mean by this is that we could send the top level object with some kind of placeholders for values that are going to come later in the stream. So here the $1, $2, and so on, they refer to pieces of information that have not been sent yet. And these are placeholders that can be progressively filled in later in the stream. For example, you can see that after the initial chunk, which is sent first, the server can fill in the header value from here and the footer value from here. Notice that the post contents itself is still not sent yet. So we actually sent the header and the footer first, but maybe the post is still being fetched from the database. So the rows of information can be sent in an arbitrary order, and we assume that the client will know what to do with the missing information. And one example of how we could do this on the client is that we could represent missing rows as promises. So here the header has already resolved, so we know what the header is. The footer has also already resolved, we know what the footer is. But because the post has not been transferred yet, we may see a promise here. And as long as our client-side code knows how to deal with missing bits of information, the promise tells us that this piece is still being sent. We haven't received it yet. So let's see what happens when we receive it. So the server can stream in a few more rows of information. So in this case, this is the post object and the content of the post, which is, this is my article. And so from the client perspective at this point, the promise for the post would resolve with this object because this object has arrived. But this time is the comments that are missing because number 5 hasn't been streamed in yet. So now there's another promise here. And this promise will resolve when the comments stream in. And so you could imagine that eventually the server actually sends the comments, which are emitted as individual rows here. And then finally, from the client perspective, the entire tree is available. So our JSON, asynchronous progressive JSON parsing, is actually complete now. Now I want to optimize this a little bit, so I think we've actually gone a little bit overboard with streaming. Like there is no real benefit to streaming individual strings if we could just kind of stream the whole array if we wanted to arrive at once. So what we're gonna do is we're gonna batch things up together depending on which operations are actually slow. For example, we can imagine that maybe fetching the post from the database is a bit slow. So the first chunk we're sending is the header and the footer, but the post is delayed. So this will be the next chunk. And again, from the client perspective, this would just mean that the post is represented as a promise. And then in the next chunk, we could send the object, the data, just for the post. And so it will have the content embedded in it. But let's say that the fetching the comments also takes a while. And so in this case, we would again emit this placeholder that this data is coming later, which again would turn, from the client perspective, it would turn into a promise that will be resolved later. And then finally, the server could stream in the comments as the remaining third chunk right here. And that would finally give us the whole tree on the client, which is a bit more compact than sending every property and every string individually as we did earlier. You can see that this format actually gives us some leeway on the server to decide when to batch things up together or when to decide to send things asynchronously. And as long as the client is able to handle chunks arriving in any order, it's actually up to the server to pick the heuristics for batching and chunking. There's another interesting optimization we can make in this format compared to regular JSON. If we see the same object reference being serialized, so for example, if there's an object that says name Dan, and then we're trying to serialize that object many times, one way we could serialize it is same as JSON does, which is just to repeat this object in the output multiple times. But because we have a way to refer to other objects within the stream, we could actually do something different, and we could outline this object as a separate row in the stream right here, and then we could have them all refer to the same row in the output. And so again, we'd have some leeway with how much we want to rely on this. So always outlining parts of the object may not be the best idea, but we could have some kind of heuristic. So maybe if we see the same object like more than 2 times, we could outline it into a row, and then next times we see it, we just reference that row. So this is really up to the server to decide how much to rely on this technique. And one kind of neat way about this is that this also lets us serialize objects with cycles, so like objects that point to themselves or to each other, because we can serialize a cycle as just a reference to the object's own row, which is something that you cannot really do in JSON. Okay, so I've described a way of sending and receiving JSON that's progressive. Should we actually use that in our apps? Well, surprise, this is actually another post about React Server Components. And what I was describing is the way React Server Components transfer the component props and the component tree, really the React tree, across the wire. And to give you a concrete example, here's a page written with React Server Components. So these are components that execute on the server only. You have the page component, with the header, the footer, and the post. And the post is async. It fetches something from the database, and it renders comments. And then the comments are also async and also load something from the database. And so React will actually serve the output of the page component as exactly this kind of progressive JSON stream. So we will see the client-side React tree. At first, it will have again, this kind of placeholder, a hole for where the content should be. And then as the load post resolves on the server, the article will stream in. But again, the comments are still pending because we're hitting the database for the comments. And then gradually, as the output of the comments component streams to the client, we will see the entire React tree materialize. But the important thing is when I say that there is a hole, it's not actually a hole that you would see as a user. This is a really important distinction because we don't actually want the page to be jumping around and randomly have holes. We want our loading states and the loading sequence that the user experiences to be intentionally designed. So going back to this example, even though this is from React's perspective, this is how the content will stream in. So there will be, it will be progressively loaded. There will be incremental bits and pieces getting filled in for as long as there are promises in the tree. the default behavior is actually that you would not see anything until the entire page is ready, which kind of sounds like it defeats the point. Like, didn't we want to stream data progressively? But the point is that we want to be able to control it as developers. And so the way you control it is the suspense component. You import suspense from React, and then you specify, here is the part of the tree that I have a fallback for. Here is a part of the tree that I have some kind of loading indicator or a glimmer for that I want the user to actually see. And so in this example, previously, the user would only see the complete thing when it's ready, but now that we've added suspense, what's going to happen is that first the post will pop in together with the header and the footer when the post itself is ready, when the post has loaded. So this will be kind of the first paint is that there's the header, there's the footer, and there's the post, and there's a glimmer for the comments. And so that will be the first visual loading state that the user sees. And then the second state that the user will see is when the comments have resolved and streamed in, the fallback for suspense will be replaced with the stuff inside of that tree. So this is a really important clarification. The stages in which the UI gets revealed are decoupled from how the data arrives. The data is streamed in kind of as streamingly as possible. So it always, whatever the server is ready to send, it always sends it, and on the client it will be assembled into a React tree. But React will only reveal the UI with intentionally designed loading stages, this intentionally designed loading sequence that you control as a developer by putting the suspense component around the parts that have some kind of good intentional visual fallback that you have designed. This might be stretching the analogy a little bit, but if we look back at how the data arrives with these inline promises, you can almost see these promises as throws, kind of saying like, I'm not ready yet. I don't have anything to show yet. And then the suspense component kind of acts like a catch. It says, well, if something is not ready here, I have something different to show. I have some kind of a fallback for this part of the UI. And so the data arrives as fast as it can in whatever order the server is ready to send it, but React takes care to present the loading sequence gracefully and let the developer control the visual reveal. Now, one thing I want to emphasize is that this technique doesn't really have anything to do with HTML. So it's a technique for progressively loading JSON, and React Server Components transfers the React tree as sort of progressive JSON, similar to what I described in the article. But of course, you can take that JSON and turn it into HTML that progressively reveals parts of HTML as it streams in. And so this is something that React also does. That's what React Server Components do on the first render, is that they can be rendered to an HTML stream. And there's an article I'm linking to that describes essentially the way React actually does it. So if you're curious, check it out. HTML doesn't have a primitive for out of order streaming, which it might eventually get in the future, right? Like this is something that maybe could get standardized. But until it does, one of the ways to do it is to stream in just the first chunk with the loading indicator, and then stream in additional data in a template tag, and then stream in a inline script that will place that new chunk of HTML into the place instead of the loading indicator. And so you could do this many times, and this way you could kind of achieve a similar thing with HTML, which is what React Server Components does for the first render to HTML. Still, I want to emphasize this technique is not specific to HTML. Again, I showed how it works with JSON, and so it applies to not just to the first load, but also to spa-like navigations between the pages in an already loaded app on the client. And so in conclusion, in this post, I've sketched out what I think is one of the core innovations of React Server Components. So instead of sending the data, the UI for the page, all the component props as a single chunk, it kind of streams your component tree from outside in. And as a result, there's as soon as there's intentional loading states with suspense boundaries that you place in your tree kind of gradually gets revealed, but you show the shell or whatever you want to show as fast as possible. And I'd like to challenge more tools to adopt progressive streaming of data. So you can see when you have the problem that the client cannot start doing anything until the server has done everything, like that's a symptom that your solution could benefit from streaming or from progressive loading. Another symptom is if one slow thing somewhere in the middle holds up the work on everything below it, that's another symptom that you might want to look at progressive streaming and consider how it can fit into your paradigm. But it's also, I also want to note that, as you've seen in the post, streaming alone is not enough because you actually want a paradigm that can take advantage of streaming and gracefully handle incomplete information, such as when something is not loaded yet, you want the program to do something sensible. And so React achieves this with giving the developer control over the reveal sequence with the suspense boundaries. I'm sure there are some other ways to handle it. So if you're aware of systems that progressively streaming data and deal with incomplete data, let me know in the comments. I'm curious to hear what kind of systems you've developed or used that have this property. Thank you.